All right, I think I'm going to go ahead and get started. And maybe if I'm starting a minute or two early, that'll net me a minute or two to talk with you all. I'm Nate Harold. I'm with NOAA's Office for Coastal Management, located in Charleston, South Carolina, where I'm a physical scientist there. I lead up our coastal change analysis program and the land cover mapping and monitoring that NOAA does. I'm also pretty intimately involved in the data and tool offerings within our Digital Coast website, if you're familiar with it. Not going to talk much about that website. I'm going to focus on the land cover work that we've been doing over the past couple of years. I had a grand vision in the anticipation of having 6 additional weeks to prepare for this presentation and conference. I intended to do a lot of comparison on some land cover products that I expected to be done, completed, and out for North Carolina. So there's a little bit of a caveat here in that those are still not done and still not out, and my comparisons are not done. But I'm going to make some comparisons that I can, and then I'm going to bring in some examples from other parts of the country where we've been doing some work and give them as much of a North Carolina feel as I can. So if you're familiar with CCAP, or if you've seen me talk in the past, you've seen some version of this slide. The area that you see here in blue is the area that NOAA considers coastal. It's kind of the immediate coastal areas and a lot of uplands that flow into that. We've been producing 30-meter Landsat-based land cover for decades now. We've updated those products essentially every 5 years for quite a while. 1996, we have pretty much in every location, and in a few areas like the Great Lakes in particular, we have data that goes back to 85 or 75, so a huge time series. We work very closely with the USGS. We coordinate our data with the NLCD data, and if you've used NLCD in the coastal area, you've used CCAP data just in a repackaged format. We are currently working with the USGS to get the 2016 30-meter land cover update released. Typically, as we provide them our CCAP data and they take it, incorporate it into the NLCD and serve it out, it's actually working the other way around this time. We're waiting for the NLCD data to come to us, and then we're going to put the coastal flare back into it. It'll actually be a re-release of all existing CCAP and all existing NLCD dates because of the improvements to the mapping methods and the change detection methods that the USGS folks have come up with. This is, in NOAA's vision, going to be our last 30-meter update. It's gotten much easier. The USGS does not need our help. In the future, we'll probably think of this as more of a historical time series, because where we're really setting our sights is at a high resolution level. Instead of producing those 30-meter products, we want to produce 1-meter products in all of those areas that you just saw on the last slide. We've done that for a number of years, primarily out in the Pacific and down in the Caribbean. You can see there's only a couple of small dots there in the rest of the CONUS area that we're interested in. Products have ranged from 1 to 4 meters, depending on the aerial or satellite imagery source used to produce them. The main reason that we've been held back from this in the past is the cost associated with producing those products. But what we've seen is those costs are starting to decrease. I've got the terms up here: faster, cheaper, and better, and that's somewhat true, though they're kind of half-truths. It's definitely something that you can do faster now, though I don't know that I'd necessarily say it's always fast, or at least that the product that you get out of what you can do fast is the product that you want. It's certainly cheaper, but the 1-meter products are still nowhere near the same cost as producing 30-meter data. And it's definitely gotten better. We've seen a lot of improvements in technology, things like Geobia, the object-based classifications, or improved classifiers like artificial intelligence. We use a lot of machine learning with a random forest classifier, and all of those things have gotten a lot better. Cloud-based computing, distributed computing, let you do a lot of those things a lot better, a lot faster. They're not perfect, though. Most of the things that get done in an automated way are very good. They get very good accuracies, but they're not what we would consider finished products for the most part. There's typically additional steps that need to go before they're fit for use for most people's purposes. So we made a decision a couple of years ago based on what was going on the 30-meter and our desire to move in this direction and those costs coming down, that we were going to start moving that way. And when you compare some of those data sets, you can see why folks' demands for that data would increase. Not only are they seeing more and more of that imagery available on things like Google Earth and Google Earth Engine, but when you start to look at this kind of level of analysis, more local or site-based analysis, those 30-meter products really don't support that kind of analysis. And when you think about it over a larger area, a higher resolution data set can provide a lot more precision. And here's just another example with a slightly simplified scheme, zoomed in a lot closer. These are not the scales at which 30-meter data is intended to be used. If you're ever seeing an individual pixel in a 30-meter data, you're looking way too close. We mentioned Geovea, the object-based. This is just one example I like to throw up. Not only are those methods improving the way that those products can be produced, but some of the quality of those products are pretty improved as well. This is one comparison comparing kind of the image-based method that you see here on your far right to more of a manually derived kind of old school product on the left. On the right, you're seeing a lot of that tidal stream network in there that if somebody tried to draw all that by hand, they might go insane and assault some of the people in their office. And just to point out some of the operational methods that we've gotten to, and this is just one example where out in the Pacific, where we've created a couple of dates of land cover and the change that exists between there. And just so I kind of lay out, typically the way we do this is detect the change, only remap those areas that were highly likely to have changed, and then insert those change areas over that original data set to create a new date of land cover. So we realized that what we were trying to do was really just a down payment in making this transition to a 1-meter product line. We knew that it was going to take us several years worth of funding and years worth of efforts, and that we were likely going to need to do it in phases. And so we've really kind of separated our effort into 2 phases. The first phase here, I'm calling kind of the initial mapping. This is the automated mapping portion of what we're doing. It's what can be done pretty easily and pretty cheaply, especially when we're doing it over very large areas and have negotiated for a volume discount in the contracts that we let out. That's the way that we do most of our work in the CCAP program. So we're mapping 1-meter land cover, 6 categories of land cover that you can see there, produced primarily off of the NAPE imagery and LiDAR data where it's available. A lot of ancillary data goes into that. These are all products that are being produced by a company called Earth Define, located out in the Seattle, Washington area. If you go to their website, you'll probably see a lot of the areas that you can see marked here as complete as being available from them and their website. I mentioned we use a random forest classifier. We have compared it to some more AI, more robust deep learning kind of things, which you'll see in some slides, but haven't seen a huge difference between the two in most of what we're trying to do. Because it's automated, there are limits. What we've seen is that the products are very good, but they're not perfect. There's a lot of blemishes in them that a lot of people would not find acceptable for the uses that they're looking to use the data for. And we're not distributing them publicly until we can start to take care of some of that, at least not in this form. And what you'll essentially see is we're kind of setting this as the foundation for our future. And then we have 2 intended uses that we'll move forward with this data set going forward. One of those will be a short term, and one of those will be a long term. And here's just a couple of examples where we've got 2 different kind of methods producing automated mapping products. Both of them are very similar. There are some differences. And essentially what I just want you to take away from some of these examples is that they're very, very similar. And no matter what the method, a lot of these things kind of get what we're trying to get to right about 85% of the time. And what we're really faced with is putting our money and our effort into trying to take those products that last 15%. And that's what we're struggling with right now. Here's one example where Dan Matting with the Department of Ag was kind enough to share a canopy product that they produced, and I've just got it up here with our land cover. The darker green is our tree category, the lighter green is our shrub category, and these products really do, they in the area of overlap, they're 85% identical. So there's probably a lot of potential advantage or opportunity for us to work together to try to take both of these products and move them both along to the final, or combine them into one, rather, I should say. And then just one more example, and you can see, some of the areas where those differences. It's here in this example. It's in the marsh area, where some of the marsh grasses that you see have a very similar spectral response and textural response to what canopy might look like elsewhere. And I told Dan, neither of these products are perfect. I just maybe happened to pick a couple of examples where I thought ours looked a little bit better over his, but he should have had his own presentation to showcase his own. So I mentioned two uses. The short-term use is that we're going to take those 1 meter products that are not perfect and resample them to 10 meters and essentially churn out what we're going to call a beta level land cover product at 10 meters. We think this is a really good way to use those products because you don't see the blemishes that you would at the full resolution scale, the 1 meter scale. But it still has a lot of detail that you do get from those 1 meter products. So when you'll see in a second, when you compare them to some existing 30 meter data, they look really good. And I kind of think of this as kind of a gateway land cover to that high resolution world, something that maybe would convince somebody who isn't sure whether investing in a 1 meter product is worth the cost, that they might see this and compare it to some other existing data and determine that it really is. We'll also throw out some percent surfaces at the 30 meter, a percent impervious and a percent canopy. For those of you who are familiar with the NLCD data, they have two similar layers. We think these ones are going to be a little bit more detailed than those, though they won't have the time series of data that those NLCD products do. So here's just an example comparing our existing 30 meter data simplified down into a much more simplified scheme on the left compared to that 10 meter product on the right. And I think you can see that they're both very similar, but that the 10 meter product has a lot more detail, particularly in when you look at the edges of those water features and the developed areas and what's within those developed areas. And this is because it's rolled up from that 1 meter level, and we're not dealing with mixed 30 meter pixels. And here's another example. This is from Myrtle Beach area. This is North Myrtle Beach. This one has wetlands included in it. And this is actually a pretty good example of what we expect that beta product to look like, where it'll have kind of 3/4 of the categories that CCAP would typically map, but won't include things like agriculture, pasture, or open space developed. And then this is just kind of an example to showcase what that 30 meter derived impervious product would look like compared to the existing impervious product from NLCD. And essentially what you see is once you get outside those road networks, 30 meter data doesn't really have a very good chance of seeing a lot of individual houses, but that 10 meter product provides a lot of areas. And then just to carrying it through, this is actually an area in Delaware where all the red is some form of development. The 30 meter data doesn't have anywhere near as much. And the reason why is because that's a lot of yards around pasture. And that's very hard to see in a 30 meter product. And there's really no hope of getting those areas correct. So I mentioned there's two uses. One was that 10 meter short-term outcome. The other is our long-term vision, taking that 1 meter product, fixing the things that we see wrong in the automated outputs, and then adding in the additional categories on top of those first 6 that we would like to map as part of our CCAP program. And essentially, this is the one where I mentioned earlier where we're spending a lot of our time and effort. We're looking for partners who might be willing to kind of cost share some of that development if they're interested in these products. And we have a lot of different pilot efforts, which I'm going to spend a couple of minutes talking about right now. But the end result is that our vision is that we would like to set up a 15-16 1 meter land cover so that come 2021, we can start updating those products. And I know that's not very long from now. So here's where we have a few of those high-resolution pilots. You can see the points scattered around. We're doing a few of those ourselves. We're working with a large array of companies to try to take advantage of their expertise and their technologies to see what they have to bear. Here's just one example of where we're spending some time editing. This is impervious cover for an area in Washington State. And essentially what you see here is all the areas in gray in the right are areas where the automated product and the final product agreed that impervious existed. All the areas in red or green are either areas that we had to remove from the automated product or add into them in a more manual way. And this is the one category that's costing us the most time and the most effort to get done. So if you've got an insight into impervious mapping, please come and talk to me. One more example, and you can just see kind of just the level of detail that's involved in these products. And then just side by side, that kind of 6-class automated versus the more complete classification scheme. And one more example. So you can see here what we do is we end up taking that generic grassland category and splitting it out into herbaceous wetlands or cultivated fields or pasture areas, open space developed, or leaving it as kind of a more natural grass feature, along with some of the other categories that we incorporated in. And then you can see this is one of the products that we just will be releasing next week on our website. It's the first of this new product line. It's for the state of Massachusetts. They were actually our first partner that contributed into the program, and they paid about $125,000 to fund the work in the state that needed to be done. They're probably a best case scenario because they had just a wealth of ancillary information and alternative imagery data sets that we could pull from. But you can see existing 30-meter products compared to these new 1-meter products and just the level of detail that's added in this marsh environment here. You can see all these pans, all the tidal creeks, and it's pretty impressive. And we know it's not perfect because it's our first one. I'm sure when we come back around to update it, we'll find some things that we want to tweak and improve the next time through. Here's another example out in Washington where you can compare that 30-meter product to that 1-meter product. And again, you can see a lot of definition in all of those waterways and in the urban areas in particular. And then I'll showcase an example here where I'll highlight what one of our 1-meter products, the Earth-defined one there labeled on the far left, looks like compared to a neural network output that we're working with a company called Ecopia Tech to produce. This is actually in Seattle area in Washington, King County. This is kind of an apples to apples approach, really just focus on the impervious. They weren't quite getting, the Ecopia Tech was not quite getting the natural areas right at this point. But what I want to point out is that not only are they mapping impervious for us at 1 meter, they're actually producing a product as a demo that we can't distribute publicly that actually goes down to the 1 foot level and has about 12 different categories of impervious in it. Things like buildings, roads, driveways, pavements, parking lots, sports fields, swimming pools. It's not cheap to produce that. It's more categories, but it's pretty impressive in terms of some of the detail that they're able to produce there. One of the things that's kind of a possibility, not just, I mentioned that we're kind of looking for partners and interested participants, but it's not just to meet our own goals. We realize that if we're pulling partners in, they very well might have need for a product like this or a product that goes well inland of where CCAP maps. If you looked at our slide earlier on, we only map about half of North Carolina, but there's no reason why there couldn't be a partnership to map the entire state. It just might be that NOAA's funding would only contribute to that coastal section. And then here's another example where we went beyond that CCAP scheme. I think this one is actually in New Hampshire, though we've actually done work in both New Hampshire and Rhode Island to go beyond just mapping a simple emergent salt marsh category. And essentially what you've got here is, about 10 different categories of salt marsh based on whether it's a pan, a pool, or a different kind of a species association within those marsh environments. And so I'm going to take this as my second to last slide here and just make a couple of summary points. I'm really seeing high resolution as our future, and it's a real game changer. If you look at a lot of the tools that we've produced and a lot of the applications that have used 30-meter data in the past, this kind of added level of detail is just completely new, and it's pretty exciting to me. The products are great. They're not perfect, but there is a very high expectation associated with those products. It's not, when you're looking at a 30-meter pixel, it's kind of debatable what that 30-meter pixel actually is or whether it's right or wrong. When you're looking at a 1-meter pixel, everyone can see it's a tree. If we're not calling it a tree, everyone knows it's wrong. If we're categorizing the shadow that comes off a house as impervious surface, everyone knows it's a shadow and that it shouldn't be impervious surface. It should be categorized as a grass because it's in the yard. Automated classification, as I stressed several times, has gotten good, but it's getting better, but it's not perfect. It's especially good in the simpler classes. As you move into those more detailed schemes, what we do is essentially use that simple classification scheme to really focus where we're working, and that eliminates a lot of the issues and error. It's easy to produce automated products, but I don't think everybody going off and doing that's probably the best answer. Having 50 people going and clicking 50 buttons and 50 products being produced isn't going to get anybody that final product. So, I think the real opportunity is in collaborating to pull everyone's resources together. And if I didn't make it clear before, it's kind of that last 15 to 20% where we're spending all the effort. The old 80-20 rule's still in effect. It's still coming back to kind of bite us in the butt a little bit. We're seeing this whole effort as something that really might take a village to get it done. Ancillary data is key. Because if there's good ancillary data, even if it's a little bit dated, that can save a hell of a lot of the effort and work, particularly in the developed impervious categories. And, I'm really interested to see whether some of those 10-meter products might be a viable alternative for some folks. Maybe kind of a happy medium between the added cost of a full 1-meter product, but with a much better level of detail than what exists in national products now. And with that, I'll say thanks, and I think we have time for questions. Yeah?
The NLCD folks are planning on going to a smaller resolution?
Right now, they're not. So their effort right now is completely focused on getting that 2016 update out the door, and it's going to be a re-release of all of their past dates as well. And it's going to include a new date in between each of their old dates. And it's going to include some additional categories that deal with the regeneration of forest and how old those regrowth stages are. So that's their emphasis. So they're adding a lot of value into those 30-meter products. And then their future direction right now, as they've shared with me, is to produce more frequent 30-meter updates. So they're targeting at least an update every other year. As soon as they get the 2016 out, they're going to start working on a 2018 with the eventual goal, I think, of updating annually, if not almost on an ongoing basis.
Your 10-meter product, are you going to align that with the cells of, say,
No. So the question was whether or not we were going to align our 10-meter product with the cells of Sentinel-2. No, we're keeping them aligned with our 1-meter product, which is aligned with the NAEP data from which it was derived. Yeah, Jeff?
How have you found the ancillary data in North Carolina to be in comparison to Massachusetts?
Well, I actually have it on my to-do list to go back and comb through that again. So we do kind of one level of effort to produce our automated products because there isn't quite as much ancillary data that we need. It's typically primarily based on the imagery and the LiDAR. LiDAR is the big one. And then any road networks and building footprints that are out there. So we use those Microsoft building footprints pretty regularly. It's not until we move into that next stage where we really start combing through that ancillary data, and we haven't done that yet for North Carolina. But the Canopy product that Dan produced is great. That's a good way to kind of validate our product, or vice versa. The impervious, that's the real key. You can get some things from the building footprints that are out there. That Microsoft one's probably gets about 90% of the buildings pretty well. You still have to find the other 10% and get them in there. Roads files have gotten very good. It's the other impervious, all the driveways and parking lots and things that are hard to get. And it's the small stuff, the driveways, the edges of roads that are in shadows, where we really need those ancillary data sets. But it can make a big difference. I mentioned Massachusetts, they paid about $15 per square mile. It'd easily be 3 times that without the ancillary data they had, and maybe even more depending on the quality you needed.
So that $15 is that for purpose?
No, that was for the full CCAP land cover scheme. But they had an impervious data set. They had a land use data set that got us a large number of the agriculture and open space categories. They had a leaf off imagery data set that let us get deciduous versus evergreen. And they had a really great up-to-date wetlands layer. So they they did, they did 2/3 of the work, which is why it was 2/3 off. Yeah.
So I get that you can't share the meter because of licensing. How did you decide on 10 meter? Why not 3 or 5?
Well, for a couple of reasons. One, because of the licensing. If it's too close to 1 meter, it violates the licensing agreement that we went with.
500 violation of that?
Yes. It's right at the cusp, actually. 10 meter also works out really well because then you're looking at 100 1 meter cells going into one 10 meter cell, and it's very easy to calculate percentages. And what we also saw was that we needed a significantly big enough area so that it was accounting for some of the slop that you see at that 1 meter level. And the smaller that window, the more likely you were to see some of those things crop up still.
So what about scale? So 10 meters, what do you think appropriate scales as far as going down are for 10 meter versus 30?
Yeah, so a 30 meter product, most people would probably tell you it's about 1 to 100,000, maybe slightly lower than that, maybe 1 to 80. I'd say a 10 meter scale, it's probably around 1 to 25, 1 to 35,000. All right, thanks, folks. And I'm here all week if you want to talk.